This video is over solving linear equations. Most of you know how to solve linear equations. So if you already know, you can skip the video, do the homework. If you have any questions, reach out for help, like always. But let's take a look and start off with our Unit 1 definitions and theorems again. Linear equation. Now, I might use this on a test here, so make sure you know what your definitions are. A linear equation can be written with one variable. In this case, we'll use x a lot. Any letter works though. But we have a variable plus a constant is equal to 0. Notice that the variable has no powers on it. It's just one x. That's why it's linear. When we solve, we get one answer. We're going to isolate the x using our properties. In class, you might have learned in the past to use inverse operations, but these inverse operations work because we are in the group of real numbers and we're using these properties. A couple of properties that we're going to look at are the addition and subtraction property. These say that I can add or subtract a number as long as I do it on both sides of the equation to keep it balanced. So if I want to add 6 to one side, I can, as long as I add 6 to the other side. The same thing works for multiplication and division. We usually see this step right here at the last end of our solving equations. So we'll have to divide both sides by c, and that is the division property to isolate our x value. We can also use the distributive property where I distribute this constant on the outside into the parentheses. So this implied multiplication here tells us that I need to multiply a times b, but I also have to multiply a times c to keep my equation balanced. The same thing if it is subtraction. And another one that we use a lot is the identity, because we're trying to get multiplication of 2x just to be 1x. I can use the identity property and the division property and solve for x. Let me just show you what we're talking about. You already know how to do this. You either know how to do this or you don't know how to do this. So let's start off easy here. 4x minus 11 equals 9. This is a two-step equation. We're going to use two properties. I'm going to use the addition property to add the 11 because we're trying to isolate x here. So this is the addition property. When I do that, that leaves 4x is equal to 20. And now I can use the division property here because 4 divided by 4 is 1. So that means that if I divide both sides by 4, I can isolate my x, giving me x equals 5. Okay? After you find an answer, you should take it back to the original problem and check your work. Make sure it works. So we're going to plug in 5. This will also help you with evaluating functions if you're struggling with that. So 5 times 4 is 20. 20 minus 11 is 9. Because both sides are equal, this works, and our answer is the answer that we found, 5. Okay, let's ramp it up a little bit. Let's include two variables on each side. 2x plus 7 equals 10 minus x in this case. So this time, really 2 terms on each side is the maximum piece of information that you want. And we can start to move it around. And you can move any one of these terms that you want. There's not a wrong answer here. Most of you are going to start by moving this x, so I'm going to go ahead and do that. Add x to both sides. So 2x plus 1x is 3x. Okay, then we can subtract 7 and divide by 3. Notice that I'm always dividing by the number the coefficient of x because I want to isolate x. And I got x equals 1. So I could plug that back in. And here, 2 minus 7 is 5. I'm sorry, 2 plus 7 is 9. And 10 minus 1 is 9. I wasn't getting the right answer. I got a little confused. Okay. But this is the correct answer. You can write them like this, or you can write it in set notation. The solution set is -1. Oops, sorry, +1. Pulling negative numbers out of the sky here. And the solution set over here is 5. So either one to write your answer is fine. If you will just go ahead and box your answers for me, that way when you put them into Gradescope, it's easier for me to read. Okay, here we go. Let's try using our division property. 5 times 2y minus 9 equals 3y minus 4. So same properties as before. I'm going to multiply out this 5 to both terms in the parentheses. Ooh. Okay. I'm going to solve this one differently. Again, you should get the same answer if you start to move something differently than I have. I'm going to move the 45 out of the way first, leaving these to cancel. (45 minus 4 is 41). Notice that I'm being very organized, keeping my rows together, rewriting my whole row when I rewrite it. I find that some of y'all will start to get jumbled, and because you're doing half the math in your head, you forget to write it down. Just be very careful here. Those tiny mistakes will change your answer. Can I not add? I mean, I guess that's fine. It's okay that we got a fraction. You can leave it in a fraction or you can estimate it. It doesn't matter to me. Okay. I want to do one more like this and then we can jump into fractions. So if you're looking for fractions, just a few more minutes and I'll do a fraction or two. Let me do a really lovely one. If you want to challenge yourself, pause me, figure this out, see if you can see where the most mistakes happen. I'm going to go ahead and distribute this 3 here. If you try to figure it out and you guessed right here, you're correct, people will forget that there's a -1 and they'll start doing crazy things like distributing this 6 or distributing this 3. There is an implied 1 right here. So this is -1 times this parentheses. I'm going to distribute that -1. So -1 times x is -x. -1 times 5 is -5. And then on this side, again, if the -1 was here, I get things like people distributing the 7. Don't do witchcraft. We're just trying to do math. Distribute your 4 to give us 4x minus 12. Now, earlier I told you we're going to try to keep 2 terms on each side. Here's a case where that doesn't happen. Again, I chose this problem for a reason because this is another spot where I get a lot of mistakes. Whenever you have like terms on the same side and you're going to combine them, just do whatever math it says. You don't have to use your inverse operations here because we're not moving them across the equal sign. So right here, this 3x minus x is 2x. And then this -6 and this -5 add together because they both have a negative sign, and then you keep the sign. So we have a bigger negative, or a smaller negative technically, to give us -11 on this side. Over here we get the same thing. 7 minus 12 is negative 5. Again, they have opposite signs. Keep the sign of the bigger number when you subtract. Okay, that's beautiful. It's a lot better looking. I'm going to start to move. I'm going to move this 2x to keep it positive. It doesn't actually matter though, okay? Add your 5. Negative 11 plus 5 or 5 minus 11. Again, two different signs. Keep the sign of the bigger number and subtract the number. So 11 minus 5, 6. Divide by 2 to isolate x. Don't lose your negative here. X is negative 3. And again, you should plug that back in and check and make sure that it works. Okay, now's the time you're waiting for. Here we go. How do you solve those pesky fraction problems? Get rid of them. Not the whole problem. You can't just skip the problem. But get rid of the fractions. So, for example, let's start off with an easy one. 5 over 3x minus 8 equals 7. Now I'm saying it's easy because there's only one fraction, right? I need you to change your mindset here. A fraction is no longer a fraction, it's division. So how do you undo that division with your inverse operations? Well, you multiply times 3. So if I take the whole problem and I multiply it times 3, my fractions will be gone and you won't have to stress about it anymore. Just make sure to distribute that 3 to every term inside your equation. So 3 times 5 over 3. The 3's cancel out. That's the point of this, because 3 over 3 is 1, leaving 5x. And then 3 times negative 8 is negative 24, and 3 times 7 is 21. Now that problem is the same problem. It's just a lot easier to solve. It's still balanced. There's nothing wrong with getting rid of the fraction. And then you just solve it just like we were. 5x equals 45, divide by 5, and x is 9. But what if we have two different fractions? So we're going to kick it up a little bit here. Well, maybe not that high. Hang on, let's calm down a little bit. Calm down. Here we go. Okay. Well, if you're fine with fractions, that's a 1/2. You can just remember your fraction rules, and you can find a common denominator and add and subtract your fractions, just like we did. But I want to go with eliminating the fraction. Let's go ahead and clear it out. To do that, we have to find at least common denominator. So I'm looking for a number that can be divided by 5. It can also be divided by 2, and it can be divided by 3. That's a crazy number. Okay, so, I think it's 30. 30 divided by 3 is 10. 30 divided by 2 is 15. 30 divided by 5 is 6, so it's 30. So I'm going to go ahead and multiply each one of these by 30. It's the same way I did it over here, except I'm writing it out for each term instead of writing it in a parentheses. Either one is fine. Okay, so 30 divided by 2 is 15. Well, hang on, I skipped a step. So let me show you what I'm doing in my head here. I'm doing 30x over 2 minus 30 over 5 equals 30 over 2 plus 30x over 3. And then I'm just going to reduce this fraction. So 30 divided by 2 is 15. 30 divided by 5 is 6. 30 divided by 2 is 15. 30 divided by 3 is 10. Now again, linear equation. Just start moving and solve. The 21, that's fun. But it's still an answer, so it doesn't matter if it's a fraction. It's just not a whole number. That's fine. Okay, so clear the fraction, work the problem like normal. I have another one, and then we can be done. If you are struggling with these, I find most people struggle trying to find the common denominator, but I picked an easy one here. Because all the denominators are 6's. So we're going to multiply everything by 6 to clear it. I'm not really going to multiply, but I'll show you what I'm talking about. Don't let this freak you out, by the way. Any number can be written over 1. And I would help your brain out in anything that has a plus or minus sign on the top of a fraction. Go ahead and group it together in a parentheses so that you don't lose anything and unbalance your equation. Okay, I'm going to reduce first before I write it out so you can see. 6 divided by 1 is 6. Times 2 is 12. Okay. Or you can do 6 times 2 is 12, divided by 1 is 12. It doesn't matter. Right here, 6 divided by 6 is 1, leaving me with just the 7. 6 divided by 6 is 1, leaving me with x. And here, if I distribute this out, then I have to go and divide it again. So I'm going to help myself out and cancel it out first, and then write the numerator. Okay, and then you can solve this. I feel like you can solve that by yourself. I just want to really see that you can clear a fraction. Trying to find another one. Just a second. Actually, I could pause you. Hang on. Okay, I found one last problem just in case. 2 over 3 times p minus 3 equals p over 6. So in this case, we want to... I always check to see if the bigger denominator can be divided by the smaller denominator. If so, then it's probably our GCF, and I can divide everything out of our fractions here. So does 6, can it be divided by 3? And the answer is yes. So I'm going to go ahead and do 6 times 2 on the top of this fraction. Don't forget your p, minus 6 times 3. And if you want, again, you could put that over 1 if it's bothering you that it's not a fraction. And then 6 times p over 6. And you can do this either direction. You can multiply and then divide, or divide and then multiply. The order doesn't matter. You'll get the same answer. So 6 times 2 is 12. Divided by 3 is 4p. 6 times 3 is 18. 6 times p over 6. They cancel, leaving p. And then you can solve this guy. Some of you freak out when this happens. Notice that one side of my equation is 0. That's okay. You can just move my 18 to the other side by adding the 18. Divide by 3, divide by 3. Just don't lose your 0. If you empty one side, make sure to put a 0 there. Okay, that covers it for today. Please reach out if you need more help on solving with fractions. Okay, don't just not do the homework. Ask me for help. Okay, bye. Have a good day.